Hello, everyone. I wanted to make a video for you to help with a couple of the optimization problems that we didn't get to in class. I am going to preface this by saying that these are more challenge problems, and they're not as well suited to be test questions. So I do want you to have help and guidance on how to tackle these, though. So with that in mind, here we go. So, a road must be built connecting a small town of Calverton. So, we're connecting this guy to Route 1 to enable drivers to reach the capital city in the shortest amount of time. Okay, so we're trying to drive from Calverton to the capital city there. How should this be done if the speed limit is 60 kilometers per hour on the road from Calverton and 110 kilometers per hour on Route 1 to the capital city? The perpendicular distance from Calverton to Route 1 is 30 kilometers, which is in here, and the capital city is 50 kilometers down Route 1, which is here. Okay, so this horizontal road here, this is Route 1. Okay. And we are trying to build a new road, which is going to be this one, to connect Calverton to the capital city. And we're trying to figure out where this junction, this corner connection should be between these two roads. So this perpendicular distance here is 30 kilometers. This horizontal distance from that perpendicular to the capital city is 50 kilometers. The speed limit is 60 kilometers per hour on the road from Calverton. So on the road to here, the speed limit is 60 kilometers per hour. And it's 110 kilometers per hour on Route 1 to the capital city. So the speed here on Route 1 is 110 kilometers per hour. Okay. So we are trying to get this all figured out. What is it that we're trying to maximize or minimize here anyway? Because this should be an optimization problem. It should be a max or min somewhere. So we're trying to build this road to connect Calverton to Route 1 to enable drivers to reach the capital city in the shortest amount of time. That means we are trying to minimize time. So since we're trying to minimize time, I'm going to write time equals, and I'm going to try to get an equation for the time it's going to take to drive from Calverton to the capital city. Okay, so we have to figure out the amount of time it's going to take to go from Calverton here to the capital city over here. But I don't have anything in times, right? The only information that I have is speed limits, right? Um, that's speed and distances, right? 30 kilometers. How do I get time from speed and distance? Well, I know how distance, time, and speed are all related, right? Distance equals rate times time, right? That's how distance, rate, and time are connected. So distance equals rate times time. So if I want to get time, I'm going to have to divide both sides by rate. So I know that if I take the distance that I have to go divided by the rate or the speed at which I can go, I know that I'm going to get time out of that. I'm going to move this down a little bit so that I have a little bit more space. Okay, so to get time, I'm going to have to take the distance that we drive divided by the rate or the speed at which we can drive. But that's going to differ, right? I've got two pieces because the speed and the distance are going to be different from this road from Calverton to Route 1 and this distance along Route 1 from wherever that corner is to the capital city. So I'm going to have to do this twice, right? I'm going to have to do distance over rate from Calverton right, Calverton, um, plus the distance over the rate from, I'll say, on Route 1, right? So we're going to have to do the distance divided by the time from Calverton, and then the distance over the rate for Route 1, and we'll add those together because this will be the time from Calverton to Route 1. This will be the time along Route 1 from the corner to the capital city. Okay, so we need to find distances and divide by the rates. Now, luckily, this picture puts a lot of these things in the picture for us. So they already told us what our variable is, right? Our variable is x. What is x? It's this distance here. It's the distance between the perpendicular corner and the actual junction where we're going to connect these two roads. That's what x is. It's the horizontal distance from the perpendicular to where we're going to build this road. And I know that the whole distance from the perpendicular all the way to the capital city is 50 kilometers, which is why this distance that we're actually going to drive along from that junction to the capital city is 50 minus x. So that's going to be the distance along Route 1 that we have to drive. And I know that I can drive along that at 110 kilometers per hour. I'm going to fill in this part because we just kind of figured it out. The distance that we drive along Route 1 is going to be that 50 kilometers minus x. And then the rate that we can drive on it is 110 kilometers per hour. So this is going to give me the time that it takes to drive on Route 1 on this horizontal distance. And then to find the time that it's going to take for this guy, we are going to do distance divided by rate. And again, they already filled this in for you. They drew a right triangle. I'm sorry, I have a lot of lines here. And so they already drew this right triangle in for you. This vertical distance, this perpendicular, is 30 kilometers. And we know that this side down here is our x. So they did the Pythagorean theorem to figure out that my hypotenuse was the square root of 30 squared plus x squared. That's the distance there. So that's the distance, sorry, that we would have to drive from Calverton. So I'm going to put that up here for the distance. That's 30 squared plus x squared. And my rate is how fast I can drive along there, which is 60 kilometers per hour. Okay, that's my time equation. How many variables do I have? I only have one variable. I only have x. So we don't have to take the extra piece of information to get this all down to one variable. It's already in one variable. That's the good news. The bad news is that now this is the equation that I want to minimize. And so I need to find the critical points of it. So I need to take the derivative of this. Now, because we have fractions, you might be tempted to do the quotient rule on each of these, which you can. But notice that the denominators in both of these are just numbers, right? So I don't have to do the quotient rule on either of these because those aren't variables, they're numbers. So before I take the derivative, I'm going to think about this as 1 over 60, just a number, times the square root. And again, to do square roots, I'm going to write that as 30 squared, which is 900, plus x squared to the 1/2 power. Because we'll have to do the chain rule to take the derivative of this. So I'm just doing a little bit of algebra here to put this into a form that's going to be easier for me to take the derivative of. And then on the second one, this will be okay. I can either take the 110 out front. I'm just going to kind of divide both pieces here by 110. So I'll have 50 over 110 minus x over 110, but I'm going to think about that as 1 over 110 times x because my brain's going to like that better to do the derivative. Okay, algebra's done so that this is in a better place to do the derivative with. Here we go. Let's start taking derivatives. To take the derivative of this first piece, I need a chain rule because I have stuff to the 1/2 power. So stuff to the 1/2 power, the derivative of that is going to be 1/2 times my stuff to the negative 1/2. So I'm going to bring the 1/2 out front. 1 over 60 times 1/2 is 1 over 120 times my stuff, which is 900 plus x squared, to the negative 1/2. That is f prime of g of x. And we have to multiply that by the derivative of our stuff, which is the derivative of 900 plus x squared, which is just going to be 2x. If you can't follow that, I want you to write out your inside function and your outside function. Do your f, do your g, do f prime of g of x times g prime of x, and you'll get here. And then I can take the derivative of this. The derivative of 50 over 100 is just 0, so I don't need to write that. And the derivative of negative 1 over 110 times x is just negative 1 over 110. Okay, this is my derivative. I have to figure out where this thing equals 0 and where it's undefined. So I'm going to try to figure out how to put this all in a fraction, because I have fractions because I've got a negative exponent here. So I'm going to write this as the 1 over 120 times 2. I can simplify that to 1 over 60. And then I'm going to have an x on top and a square root down here on the bottom. So I'll just write this as 1. Sorry, sometimes as you are trying to figure out how to simplify this, you learn a little bit more about how you want this to look. All right, so the 60 was on the bottom, and I had an x on the top from here. This is on the top, and then this square root is going to be moved to the bottom. So I'm going to have the square root of 900 plus x squared down here, and then minus 1 over 110. Okay, now I could get a common denominator here. And yeah, let's just do that. We'll get a common denominator. So I'm going to multiply this guy by 110 over 110. I might be able to get a smaller one, but I'm going to multiply this by 60 times that square root, because that's the easiest way to get a common denominator. And this one is really ugly. So you might be able to find a smaller one. I'm just going to kind of go the easy way. And so this is going to be 110 times x minus 60 times the square root of 900 plus x squared, all over whatever 60 times 110 times this beautiful square root is. Okay, that's my derivative. Okay, I'm going to set the top equal to 0 to figure out where my derivative is equal to 0, and I'm going to set the bottom equal to 0 to figure out where my derivative is undefined. Okay, so let's set this top equal to 0. So I'm going to have to solve out where 110 times x minus 60 times the square root of 900 plus x squared equals 0. I can add that 60 times the square root over. Okay, now because I have a variable stuck underneath that square root, I'm going to want to square both sides. Before I do that, I'm going to divide both sides by that 60 just to get the square root by itself, so this gets less gross. So if I divide both sides by 60, 110 divided by 60, that can simplify to 11 over 6, so I'll just do that. And then I'll have the square root of 900 plus x squared over here. Now I can square both sides to try to simplify this and get rid of that square root. And so when I do that, I'm going to get 121 x squared over 36 is equal to 900 plus x squared. Okay, I've got x's on both sides. If you want to, you could subtract the x squared over. I think I'm going to clear my fractions because I don't like fractions. So I'm going to multiply both sides here by 36. And when you multiply here, these guys go away, and I just get 121 times x squared. On the other side, I get 900 times 36, which let me put that into my calculator. I get 32,400. Okay, 32,400, and then plus 36x squared. Now I can subtract that 36x squared over 121 minus 36 gives me 85. X squared's over here. And I still have this 32,400 over here. So I'm going to divide both sides by 32, or by that 85. And so I'll get this. And then square root both sides. We're getting there. So that means that x is equal to the square root of 32,400 divided by 85. Okay, if you wanted to, you could put that in your calculator. For me, you can just leave it like that. If achieve wants a decimal, you can put that in your calculator. I get about 19.5237. And this is an x value. X was a distance, and our distance here is measured in kilometers. All right, so that's going to be a kilometers. So that's the critical point that I get from where my derivative is equal to 0. Now let's look where my derivative is undefined. So we would have to set this whole thing equal to 0. Notice you can divide both sides by 60 and 110. Really, this means that 900 plus x squared would have to be 0 to push this whole denominator to 0. But that means that x squared would have to be negative 900. There's no solutions to that, right? You can't square something and get a negative out. So that means there is nowhere where this thing is undefined, which means that this is my only critical point. That shouldn't be the min that I seek. Now, this is a case where to do the second derivative test, you'd have to take the derivative of this again. That's going to get really gross. I don't have space here to do that. You could fight through it. But notice that when you do all of these derivatives, you're going to get a positive number times a positive number to a negative exponent. That just pushes us into a denominator, but it still keeps everything positive times something positive. So I'm always going to get a positive even out of my second derivative when I find it. That means if I get a positive out of my second derivative, my entire original function is concave up, which means what I have is in fact a min, which I wanted. So sometimes it's just really gross to find that second derivative, but we can kind of logic through the fact that our second derivative is going to be positive everywhere, and that means this is going to be the minimum that we seek. So how should this be done? We are going to build this connection point between Calverton and Route 1 about 19.5 kilometers to the east of this perpendicular point P. Okay, so that is that question. Let's move on to the last challenge problem that we have here. Okay, all units in a 30-unit apartment building are rented out when the rent is set at $2,000 per month. A survey reveals that for each $100 increment, for each $100 increase in rent, the demand for apartments will decrease, causing one additional apartment to go vacant. Suppose that each occupied unit costs $200 per month in maintenance. Which rent maximizes monthly profit? Okay, so what are we trying to maximize or minimize here? Yep, we want to maximize profit. That means I'm going to write profit equals and I'm going to figure out how to get an equation for profit out of all of this stuff. Okay, so profit from business, from some of my business classes in college. Hopefully, you guys have seen some of this before, and even I think you might have seen this in other classes as well. To get profit, this is the money you have left, right? After paying all of your bills and getting all of your income, right? So, profit is what you have left over. So, it's money in minus money out. Your money in is your revenue, right? That's the money that's coming into you, minus your cost, which is the money going out. That will tell you how much money you have left over. Okay, so profit's usually revenue minus cost. And we have to figure out how to get revenue and cost from all of this stuff. Okay, so revenue is money in, cost is money out. All right, if you are trying to maximize your profit, you're the one that owns this apartment building, right? So your money coming in, if you owned this apartment building, the money coming in would come from rent, right? So our revenue is going to be the rent. When all of these apartments pay their rent, that's going to be the money coming in. And we're going to have to subtract the cost, which, do we have any costs here? Right here. Each occupied unit costs $200 in maintenance. So our money out here is the maintenance to keep all of these apartments running, essentially. So I'm going to have to figure out how to get all of the money that comes in rent and how to get all of the money that goes out in maintenance. And I'm going to subtract those to get my profit. And then I'll have my equation. Okay. Let's think about this. How are we going to do this? Well, right now, a 30 unit apartment building is all rented out. So I have 30 units rented. When the rent is $2,000 per month. And I know that if I increase rent by $100, that means the number of apartments goes down by one, right? So every time I increase the rent by 100, I lose an apartment. And that means I'm going to have less money coming in. So we want to kind of balance this out so that increasing rent will bring more money in, but it loses us apartments, which is going to lose us money as well. So we have to figure out how this is all going to work out. Okay, so let's think about how this is going to work. We need to figure out, because it says for each $100 increase in rent, I'm going to have to figure out how many $100 increases in rent I want to do, right? So let's make that my variable, because that's what I need to figure out. So I'm going to say X is the number of $100 rent increases. Okay, so now let's think about, what if X is 1? How many apartments will I have, and what's the rent going to be? So if X is 1, I'm increasing the rent by $100. If I increase the rent by $100, we started the rent out at $2,000. So if I increase it by $100, my rent's going to go up to $2,100 per month. But if I increase it by 1, I'm going to lose an apartment. I started out at 30 units being rented. I'm going to lose 1. So that means I'm going to have 29 apartments left. Okay. What if I do 2 $100 increases? Well, if I increase the rent by $100 twice, I'm increasing it by $200, which means my rent is going to go up to $2,200. But I'm going to lose another apartment, so I'm going to be down to 28 apartments that are rented out, right? And we could keep going. What if I rented the rate, if I raised rent by $100 a third time? Well, I'm going to lose another apartment, so I'm going to be down to 27 occupied apartments, but my rent's going to go up by $100, which means my rent is going to go up to $2,300. Okay, so what if I just have X as X? I'm going to increase the rent X number of times by $100. So that means I'm going to lose X apartments because I increased the rent X times, which means I'm going to lose X apartments. So I'm going to have 30 minus X apartments left. That should make sense with everything that we've done here. And if I increase the rent X number of times, I'm going to start out at $2,000 and I'm going to add $100 X times. So this will be my rent. And that should kind of make sense with the numbers that we had here. I'm just trying to go from specific numbers to find patterns to get to my general kind of equations here. Okay, so with that in mind, let's try to figure out how to turn all of this into revenue and cost, which will then give us profit. All right, revenue is the money coming in rent. So if I make X increases in my rent, this is the number of apartments that I have, and this is the rent that they're paying every month. So how much revenue, how much money's coming in? Well, each apartment is going to pay the rent. So I'm going to multiply the rent by the number of apartments to figure out how much total money is coming in. So my rent is going to be the number of apartments times the rent per apartment. So I'm going to have 30 minus X apartments times 2,000 plus 100x dollars per month. That's going to give me the total amount of money coming in. Okay, and then I'm going to subtract from that the cost. That's the money going out, which is what we pay in maintenance. We have to pay $200 for each occupied unit. So if I make X $100 increases, I know how many apartments will be occupied. It's going to be 30 minus X. And I'm going to have to pay $200 for each of those apartments. So the cost, the money I have to pay for maintenance, is going to be the number of apartments, which is 30 minus X, times the amount of maintenance, which is $200 for each apartment. That is my cost, the money going out. And that's my profit. It's money in minus money out. This is my profit equation. This is what I'm trying to maximize. So now we have to take the derivative of this. So to take the derivative of this, you have options. You can either do a product rule here and a product rule here, and just be very careful with this negative sign. You have to subtract the entire second product rule. Or I can distribute everything out in my original function and then take the derivative from there. In class today, it seemed like everybody preferred to expand things out and try to avoid the product rules. So I'm going to assume that you continue to feel that way, and we will distribute all of this out. So I'm going to FOIL all of this. 30 times 2,000 is going to be 60,000. 60, yeah, that's right. And then 30 plus 100x is going to be plus 3,000x. And then my inside negative x times 2,000 is negative 2,000x. And then my last negative x times 100x is negative 100x squared. And then I'm going to have to distribute both the negative and the 200, so be careful with that. I'm essentially distributing negative 200. Negative 200 times 30 is negative 6,000. And negative 200 times negative x is plus 200x. So now I have everything FOILed out and we have to just combine like terms. So let's see, I'll start with this is my only x squared. And then I've got a couple of x's that I'll have to add. And then I've got a couple of numbers that I'll have to add. So those are my like terms here. So my profit, again, I haven't taken a derivative yet. This is all just algebra to make this look okay, to be able to take the derivative. That's negative 100x squared. I'm going to combine all my x's. 3,000 x's minus 2,000 x's is 1,000 x's, plus another 200 x's is going to be 1,200 x's. And then I've got 60,000 minus 6,000, which is going to be a positive 54,000. Okay, this looks better. This is my profit function. This is what I want to find the critical points of. This is much nicer to take the derivative of. So from here, hopefully the hard part's over. Let's take the derivative. We're going to get negative 200x to the first plus 1,200 plus 0. That's my derivative. Notice this thing's defined everywhere, so I don't have to worry about the undefined part. So I just have to figure out where this is equal to 0. So I'm going to add the 200x to both sides. 1,200 equals 200x. I'm going to divide both sides by 200, and I'm going to get x equals 6. Awesome. That's my critical point that should maximize this monthly profit. Is this definitely a maximum? Well, let's double check this. What's my second derivative? It's going to be the derivative of this, so that's going to be negative 200, and that's it. So my second derivative is always negative, which means I'm going to be concave down everywhere, which means this is, in fact, a max, which is what I wanted. So I can be sure that I am at the correct critical point. So now I know that x is 6. And remind me, x was the number of times that we increase the rent by $100. So we're going to increase the rent by $100 6 times. And so we're going to increase the rent by $600 total. So to answer the question of which rent will maximize monthly profit, our rent is basically going to be this. We're going to take that $2,000 that we started with, and we're going to add $100 to it 6 times, and we're going to end up with a rent of $2,600. That is the rent that's going to maximize our monthly profit. All right, I hope that helps with some of these challenge problems. Again, the process here is always the same. Even though every problem is different, the process is the same. What are you maximizing or minimizing? Find an equation for that thing that just contains one variable, and then take the derivative and set it equal to 0, or find where it doesn't exist to find your critical points, and then just make sure that the critical point you have is the critical point you want and answer your question. All right, you've got this. Happy grinding on this. I hope you have a lovely weekend and have a happy and safe Halloween.